Fight.
Welcome to The Hotspot. I'm your host, Arman Dezfuli-Arjomandi. Today, we have two guests. Our first guest is Boris Resnki, founder of FreedomFi. Many of you may be familiar with FreedomFi as the partner who's helping Helium deploy their first 5G network in the United States. And our returning guest is James Fayal, the unofficial economic guru of Helium. This is an amazing discussion with tons of detail, including the 5G launch plan, potential exploits, carrier deals, and so much more. I think Boris and James do an excellent job of answering all the tough questions that I throw at them in this interview. Before we get started, I want to clear up some terminology. You'll hear multiple mentions of the term MNO and MVNO in this interview. These two terms represent different types of cellular wireless carriers. MNOs are mobile network operators. These are the big brands that serve the majority of customers in any given region and own most of their own infrastructure. In the US, examples of these are AT&T, T-Mobile, and Verizon. MVNOs are mobile virtual network operators. These are smaller players that don't actually own any radio infrastructure or spectrum licenses. Rather, they make deals with the bigger MNOs in order to allow their customers to roam onto the MNO's infrastructure. Examples of MVNOs in the United States are Boost Mobile and Republic Wireless, and there are many more. If you understand the difference between an MNO and an MVNO, that should give you a lot of insight into what we're talking about in this conversation. And with all that out of the way, here's my discussion with Boris and James. Boris, James, welcome to the show.
Thanks for having me back on, Arman.
Yeah, thank you for having me first time.
Yeah, of course, Boris, you're the most requested guest we've ever had. So I'm really happy to have you on here. And of course, James, I think people are always interested in hearing your ideas. So let's spend a moment talking about what Helium is. At its most base layer, Helium is a set of technologies spanning blockchains and wireless networks. Now, as of now, people understand the network as somewhat of a utility for low-power sensors, but ultimately, Helium has the potential to be much more than that. So after 2 years of the network being live, I think it's time to reflect on the success of the LoRaWAN build-out, over 160,000 hotspots and thousands of cities covered, and start thinking about how Helium can take the next step and evolve into a multi-protocol, or as we like to say, Omni-Protocol network. So the first evolution past LoRaWAN is 5G. And I think a lot of people are really excited about this. Helium had vague plans for 5G or cellular for as long as I can remember. I'm sure I interviewed Amir about it in my first episode, and we talked about cellular, and he was throwing out some idea about, this is a direction that we could go in, but never was there a really solid plan, from what I understand, until Helium met FreedomFi. And Boris, you are the founder of FreedomFi. So I'd love to know a little bit more about that. I think people are interested in knowing how that happened. What did Helium come to you guys with? Did they come to you? Did you come to them? What was FreedomFi before this partnership? And what is FreedomFi?
My personal background is in open source infrastructure. And I've spent probably at this point 13 years of my professional career in open source software. Prior to FreedomFi, I helped build a company called Mirantis, which now actually is a pretty sizable open source distribution company focusing on a project that pretty much everybody, I think, in the open source ecosystem knows, called Kubernetes. It's like a data center automation software that at Mirantis we pre-package and make it enterprise usable. And the FreedomFi story actually has its roots while I was still at Mirantis, because a lot of the open source stuff we did at Mirantis actually was used by telecom operators. And we have Ericsson as one of the big investors in the company, and hundreds of telecoms actually using the Mirantis stuff. And while at Mirantis, I was always, on one hand, amazed by the extent of disruption that open source brought to the enterprise data center space, with everything, starting with things like Linux and SDNs and open source databases and all of the stuff. And at the same time, with some exposure into the telecom world, I was always puzzled by how little of that disruption has penetrated into the telecom market, where most of the infrastructure is still very much based on a few incumbents moving large, expensive hardware boxes. So about 3 years ago, we met a team at Facebook Connectivity that came to us while I was still at Mirantis, and they said, hey, we have this cool thing that we're doing. We're building an open source telecom network core. But instead of religiously following FreeGPP architecture principles, and FreeGPP is this common standards body in the telecom world, we're going to approach the problem from completely a blank sheet of paper and rethink about it. How would we, build it if we were just building like an enterprise software-defined network? And that was a very interesting idea, and I very quickly jumped on it. We worked together to basically seed the prototype of that project that now has become this project Magma, and install it in a couple of POCs at a couple of telcos. And I, throughout this entire process, was kind of like the champion of Magma inside Mirantis. And then at some point, it's become clear that this could be like a whole separate business altogether. And in January of 2020, if I'm not mistaken, we basically took it and spun it out into a separate company called FreedomFi. And the idea there is that we'll take this open source software called Magma and we'll package it such that we can consumerize effectively the deployment of cellular networks and change the problem from it being this complicated multi-year enterprise type project of, deploying large network to basically enable anybody to be able to plug in a small cell into the FreedomFi gateway and have their small scale cellular network running. And that's kind of like the original vision behind FreedomFi that has become an enabler to the, this Helium 5G concept. And the way that started is shortly after we launched into beta, which was, I think, October of last year, Abai, also known as Hashcode in Discord, he pinged me on Twitter and he said, oh, that's you guys are consumerizing cellular deployments. And we've come up with this, ingenious model for how to incentivize bottoms up network build outs and proved out the model using LoRa network. Can we potentially marry the two concepts and expand Helium into the cellular paradigm? And I have been, kind of a long crypto fan, and I've already owned the Helium hotspot at the time. So I was like, yeah, let's do it. So we did a couple of POCs just to make sure that this whole thing is possible. And then, in April, we kind of went public with it and announced and said, hey, we're going to try and make it happen, make this thing fly. And ever since then, I think 70% of everything day to day that we've been focusing on is trying to make this thing actually work at scale and working with the operators and making it, even more plug and play than we originally had it, and et cetera, et cetera. So that's the background.
Wow, what a lucky marriage of two very symbiotic ideas. I mean, how crazy is that you guys basically had the infrastructure model and the deployment model, and then Helium came in with the economic incentive model. And I find it really interesting that you say you had a hotspot. So you were aware of Helium before Abai even reached out to you. Did you not think to reach out to them?
I did, and I was almost about to reach out myself. So when I saw it actually on the phone, I'm like, yes, that's it. Great. It was very, very exciting. If Abai wouldn't have reached out, I probably would have reached out myself 2 weeks into it. So
did you and Abai talk about what Helium was planning to do at the time for cellular, or if they had their own plans, or did he just say, hey, this is the first step we're looking to make, we want to do it with you guys? When
we had our first conversation, we didn't get a lot of history or background on Helium being anything other than a LoRaWAN network. So we were on day one told that the idea was to make it more than just LoRaWAN. I think that effectively our conversation together was the first foray into this concept that we are now referring to as, the Omni-Protocol Helium, so to speak.
Right. So you two work together, and now there's this thing called HIP-27, which is basically about bringing CBRS 5G onto the Helium network. And it's a pretty big change. I mean, it actually fits quite well into the model as is. with the whole concept of data credits, but there's a lot of technical things that need to be changed in order for Helium to evolve past just LoRaWAN, because it's basically like a database built for one type of service, and now it's servicing two different types of service or two different wireless protocols. How did HIP 27 come about? Who's the author on that, and how many revisions did you go through before you presented that to the community?
So we've gone through a number of revisions, and the author of it was myself with the help of some of the Helium folks, including folks like Abai and some other team members on the FreedomFi side that are, arguably more versed in cellular wireless than myself. The genesis was driven, just like you have mentioned, by the fact that as soon as we started kind of going deeper into this concept of expanding Helium into CBRS 5G, we understood that there's a number of things that need to be changed, starting with a very basic notion of data credits being currently denominated in terms of like a certain number of bytes. And obviously, this doesn't work if you're going into the multiple protocols, because with different protocols, the data is priced differently. Moreover, when you are actually touching on cellular, the data is priced very differently depending on the time of day and the geographic location and all these kinds of things. We kind of took a holistic look at how the Helium blockchain behaves. And the original HIP 27 was actually quite a bit longer than what you see today. And it did encompass also some of the proposed changes to actually a proof of coverage algorithm as well. The first revision that we floated to the community had basically a proposal that what we do is we decouple the denomination of data credits from this, hard number of bytes and make that a chain variable. And then also introduce a mechanism for basically like plugging in various proof of coverage protocols. And we had a first stab at the implementation of proof of coverage for CBRS and Wi-Fi at the time. And shortly after we floated that to the community, we got a lot of feedback, which in hindsight was very good feedback, in that, our POC implementation proposal, while makes a lot of sense, is also very easy to hack and game. And we were coming at it from a little bit of like, private cellular enterprise mentality. So, we were just more thinking about like, how can we make it work such that it's efficient? We never thought about it from the standpoint of like, we're going to throw this thing out there and, tens of thousands of people are going to be trying to figure out how to game this thing. We didn't even like think about it from that standpoint. And the community immediately gave us feedback that, okay, this is a hole, that is a hole, that is a hole, that is a hole. And in the end, we had to basically abandon the proof of coverage part of the HIP 27 and say, okay, forget that part. We're just going to focus on the DC decoupling from the fixed set of, amount of data. And we'll limit HIP 27 to that. And then we'll come back and see if we can tackle the proof of coverage part in a later HIP. So that's a little bit of history behind HIP 27.
Yep. I remember this pretty clearly, that you guys presented HIP 27. I loved a lot of what was in it, but I think I was also one of the dissenting voices, not necessarily on a technical level, even understanding all the details, but just saying like, wow, this is a great proposal, but it seems to be doing a lot all at once. And I'm worried about how likely it would be to even get this passed and get this reviewed and understood by enough people in the community. So now we have two different HIPs. We've got HIP 27, which is the original CBRS 5G HIP, and we've got HIP 37, which is the proof of coverage side of things. Now, I want to talk about HIP 37, get into that a little later. First, it's important to sort of go over 27 and help people understand exactly what that is, what are the changes proposed, and just to be clear, HIP 27 has been approved by the community.
It has been approved, that's correct.
Great. HIP 37 is up for discussion. And yeah, I just want to like comment a little bit on how interesting and complex of a change even HIP 27 is. It basically takes Helium from, first of all, 1 to 2 protocols. But not only that, the first protocol, LoRaWAN, is like an enclosed system. It's a enclosed system. If anyone else was building on other LoRaWAN networks previously, they have to like reconfigure their devices to work on Helium's LoRaWAN network. And as of now, there is no sort of roaming between LoRaWAN networks. It's just you use the Helium network. That's what you use. You make a single commitment. And it was a fresh start, right? Like there wasn't an existing network that was taken over by this protocol or sort of bought into. It's like the Helium network, although using an existing protocol, was building from, on a physical level, a completely fresh start, new hotspots, broadcasting on the 915 megahertz frequency, a network that had never been used before, didn't even exist before Helium started.
At least in the US, yeah. In Europe, there was some build out, but completely fresh essentially in the US.
Well, yeah, there was build out of other LoRaWAN networks. I guess what I'm trying to say is that the Helium network did not exist at that point. Like it's a completely fresh start. And it's just not like that in the cellular world. There's so much more complexity. There are tons of incumbents. Like we all have cell phones. They use existing carriers, and there is just no real way to pragmatically start your own carrier and start from scratch the way we did with LoRaWAN. It really has to be this interoperation of the Helium network's cellular side with existing systems, existing carriers. I think that's a tremendously complex and interesting problem to solve that I'm sure has many challenges. Before we dive into HIP 27, I'd love to know a little bit more about what the exact complexities are. What is the opportunity here, and how do we integrate Helium with existing carriers and existing cellular networks?
Yeah, so I have a couple of slides that actually, I think, attempt to explain what we're trying to achieve with this first step of moving Helium into the cellular wireless paradigm, and what actually even makes this possible today. To level set, first, it's important to understand how the cellular wireless industry works. The first kind of underpinning core concept about everything in cellular wireless is that it's very much a top-down model, where basically, if we're talking about building out cellular wireless infrastructure, it all starts with some network operator buying spectrum from the local regulatory agency, which in case of US is the FCC. And you buy a chunk of spectrum and you own it, or you effectively lease it for a certain period of time, and that spectrum just belongs to you. Then what you have is that operator would typically contract out to some of the large incumbents like Ericsson or Nokia to build effectively like a proprietary set of boxes, both on the radio side and oftentimes on the software side as well, that are specifically designed to operate against that chunk of spectrum that basically this carrier has purchased. And then they contract out the install to folks like Crown Castle or American Tower that have limited but large set of vertical assets where those radios get mounted to. And then ultimately they sell the service to the consumer. And this is the standard carrier top-down model that we have seen everywhere. Now, what's been happening lately is we started seeing an opportunity for like a completely new model, and that is a bottoms-up, what we refer to as a community wireless model, which to a large extent enabled by commoditization of the software and hardware stack in the telecom. So the example that I was giving with like Magma open source software, that did not exist before. Like you need to go to Ericsson before to buy, a telecom network core. You couldn't just go and like get an open source piece of software that'll enable it. And another kind of important component that enables this is just loosening of spectrum regulation. I mentioned that, the story here started with the operator buying the spectrum. Now with CBRS in US, anybody can get interference-free spectrum with just a credit card. And this is a brand new program that literally started just a year ago, where you can just have a contract with the spectrum access system operator and get a chunk of spectrum, and you pay on as-you-go basis. So all of these things combined are enabling what we refer to as this community wireless network model. And the way that this model works is that anybody, it can be like a municipality, like a city, or it can be a small business, like a coffee shop, or it can even be just like an individual with maybe like a house on top of the hill and a good view of the city, can get access to the CBRS shared spectrum, buy a commodity small cell, and CBRS small cells are sold online. You can just Google CBRS small cells and you'll see them, for sale, a diversity of them, and basically deploy the radio anywhere, wherever, they're located, and then effectively sell that network capacity up to an operator. And if you look at, the way that the networks operate today, 100% of them, I would say, maybe with just a few tiny exceptions, like in more progressive places, telecom-wise, like Asia, they're carrier wireless type of networks that are built top-down. Now, if you look into the future, we strongly believe that it's going to be kind of a coexistence between the carrier wireless networks and the community wireless networks, which is what we're trying to pioneer with Helium, that are deployed bottoms up. And to the point that you have made earlier, to understand that we're not just saying that, hey, we're just going to build this Helium network, we're going to kill AT&T, we're going to kill Verizon. That's not what we're doing. We believe that there's going to be probably like forever, in fact, this coexistence that is going to be happening between the macro carrier networks that are being deployed by the incumbent operators and these community deployed offload networks that are now enabled by a whole bunch of, technology disruptions that have happened recently. Now, I think it's also important to understand, like, with respect to Helium, how do we envision this happening? So I've talked a little bit about the story of FreedomFi, and what we make is we make this generic x86 based appliance called the FreedomFi Gateway, which basically is, it's almost like a network switch that anybody can take a CBRS small cell and plug it in, and it will get automatically configured, and you have basically a single node cellular network. This is a little bit of what the actual product looks like. We've shared some of these pictures in the community presentations before, but the important distinction between the standard Helium hotspot and the FreedomFi Gateway that I wanted to make, that I think at this point most people understand, but not 100% of the people, is that the FreedomFi Gateway by itself is not like a cellular antenna, and it's not a small cell. It's almost like a network switch, which has a LoRa concentrator embedded in it, but it also has this extensibility whereby you can plug in various cellular antennas into it to basically extend the network. And we're starting with specifically CBRS cellular antennas, or small cells as they are called in the industry. But our plan is to, over time, expand it to Wi-Fi 6 and potentially also small cells that operate in other spectrum bands. Therefore, and this is kind of like where this concept of Omni-Protocol network comes into play versus just, CBRS Helium network. And in that spirit, also, everything that we have done in terms of structuring HIP27 and then consequently structuring HIP37, it wasn't geared exclusively towards specifically CBRS. It was geared towards, okay, we'll move into CBRS, but how do we actually make Helium an Omni-Protocol network if we wanted to move into Wi-Fi, or if we wanted to move into like millimeter wave bands later? So we, by design, tried to make it generic. Another picture. So this is actually what the initial sort of cellular mining bundle would look like. This is, the FreedomFi Gateway. This is the small cell that is the first small cell, indoor small cell that we have certified to be plug and play. That's going to be available to be kind of purchased in a bundle together with the FreedomFi Gateway. And over time, as I mentioned, the plan is to expand dramatically the amount of small cells and other devices that can be pluggable into the FreedomFi gateway to expand Helium network into a variety of spectrum bands and protocols. Again, this is kind of a generic slide from our corporate deck about how to build private LTE or private 5G network using these components. But the thing to understand here is that there's 3 steps. First is you get a certified small cell or later Wi-Fi 6 access point. You plug it into the gateway, and then this system will self-initialize and it will effectively become an offload node for the carriers with whom we've built relationships to offload cellular data into. This is another slide that we've shared with the community before and now is also published on our website about what we plan in terms of what the shipping timelines are. So this month is going to be a huge month for us. We plan to start shipping on September 28th, and it looks like we will be able to ship on September 28th. We'll also be announcing our first offload partner, so the first company that is going to be offloading data into the network. We wanted to basically proactively start socializing what now has become HIP 37, but here it's a little bit of an old slide. We refer to it as HIP 27 proof of coverage piece with the community. October, we will start kind of ramping the shipments. And in October, in addition to just the gateways, we'll also be shipping via CBRS indoor small cells. Through the January of next year, we'll basically aiming to satisfy all of the waitlist that we currently have and get to some meaningful scale. And also, I think importantly, introduce our first Wi-Fi access point that can be plugged into the gateway. And the reason why that's important is because this will also address a big community concern about, us just focusing on US, because CBRS is just a US thing. With Wi-Fi, we will be able to actually take Helium into this Omni-Protocol realm in places outside of US.
Great. Thank you for that. I think that was a really great overview of just everything you guys are going for. There's a lot going on here. It's lots of complexity. And, I'm sure 99% of the complexity is masked from all of us, even from me and James, right? All the under the hood stuff with Magmo, the carrier deals, and just all the amount of crazy code and coordination that needs to go on here is really, I can't even imagine how large it is, but it must be. That photo of like the iceberg and that there's just a little bit above water, but underneath is like this gigantic mass.
Yeah, no, I mean, I agree. So it's been a crazy few months.
Yeah. So just to distill a little bit for everybody, all the terminology here. So 5G is really the technology that we're working with here. It's the next generation of cellular networks. Many carriers have already rolled it out in the US and worldwide. CBRS is the Citizens Band Radio Spectrum. So that is just simply the radio license that FreedomFi is essentially using to help Helium deploy this cellular network. HIP 27 is really more about the technical implementation of how does this larger piece of cellular infrastructure work with the Helium blockchain. HIP 27 is actually quite short. I think it might be the shortest approved HIP in terms of like number of characters. It's very simple. If you could just explain briefly what HIP 27 does.
Yeah, HIP 27 basically says that, hey, first of all, we want to try and take a stab at making Helium an Omni-Protocol network, although the word Omni-Protocol does not come in Helium 27. And the specific change to enable that, the specific small change to enable that we will adopt is that we will decouple data credits from the fixed number of bytes and introduce a chain variable whereby, depending on the protocol, we can dynamically adjust the conversion. And we'll put a stake in the ground and say that for the cellular data, that is the Helium 5G data that's going to be coming onto the network, we will sell it at 50 cents a gigabyte. That's it. And that's the HIP. So it's a little bit of a, I would say, basic from the technical standpoint, but it's a very important and strategic leap, I would say, for the Helium network at large, in that it's the first HIP where there is stipulation of Helium moving beyond being just a LoRa network and actually doing some small but important tweak to enable that.
Yeah, I think honing in on the small but important tweak is really what's key with HIP-27. I've seen some criticism of the pricing scheme and, well, don't we need different pricing for different countries, and don't we need dynamic pricing, and what about letting each hotspot operator, set their own pricing? And I agree, those seem like important things, but I've learned through building numerous projects throughout my life that if you're really trying to do something big and take a big step forward in what's possible, it's super important to focus on like sort of the minimum viable product and not create too much variation outside of where it needs to be created at the get-go. And James, I'm sure you have something to say here as well.
Oh, yeah. No, I've definitely with projects I've worked on in the past, my own company's ST. And, I think there's sort of a trend in the HIPs now that we're seeing a lot of like HIP 17, HIP 15, HIP 27, HIP 37. God knows when we were talking about HIP 37 that there was like 3 or 4 things that we like to split off. We're like, that's still too much. And like I'm working on redenomination idea, which was tossed around as possibly being part of this HIP. So I think narrowing that scope, even still with HIP 37, super important to make sure that we can get something through to the community and make sure that something actually gets out there. Don't let the enemy of good be perfect.
Yep, that's exactly right. And that was basically the point of HIP. Like the idea there was just to move forward quickly, right? Because we threw it out. We said, here's a whole bunch of changes we need to do to make actually a Helium work for cellular. And then we kind of got stuck in this, this is hackable and this is not going to work and this can't be a chain variable and this should be a chain variable and da da da. So there's a lot of complexity we have to deal with that even don't have to do anything with the economics of the Helium blockchain. Let's just leave like a small piece of it, which is the thing that absolutely needs to be done, which is decoupling of data credits from the fixed amount of data. Leave it at that and make it sort of like, okay, we have now as a community adopted that we want to try and adventure into this new direction, get it approved, and then continue moving forward and refine the nuance as we go.
So with that context in mind, let's start talking about HIP 37, which is the piece that was split off from HIP 27. It was initially in there. You decided to pare it down, which I think it was a great decision. And James, you've done a lot of work here on the economic side of things. Boris, you've done a lot on both the economic and the technical implementation side of things. And James, I was hoping you could give us just a brief economic overview of HIP 37. Why is this necessary? What does it stand to achieve? And why should the community essentially approve this HIP?
As Boris discussed, the overarching idea of HIP 37 was sort of providing a incentive mechanism to help build the CBRS network, in this case, any future protocol, or to turn Helium into an Omni-Protocol network. And to be able to do that, there were some structural changes with the economics of Helium that we thought we had to adjust, because as you said earlier, the system was made for one protocol, even if we had multiple protocols in our head. And God knows, back to even like when the community was on Slack, I remember like there was like I think it was a Wi-Fi like one, and it like came and went. So people have been talking about Omni-Protocol forever, but to be able to make that jump, there's some pretty significant economic things that need to happen. And the first one is a bit of a formality in some ways, that we have the POC bucket of rewards, and then we have the DC bucket of rewards. And that was designed so that over time, the rewards going to people doing legitimate data transfer on wireless networks would slowly become more and more of the rewards issued by Helium at every month. And when the DCs went live and started to be rewarded, people gamed the hell out of it. And I think, Arman and I definitely remember those days. And the community, it was a pretty chaotic period. Abe came out with HIP 10 that essentially said that you cannot be rewarded for data transfer any more than the cost of that data. And it just removed a lot of the gaming concerns. And what happened to the excess rewards, because there was not nearly enough data transfers to sort of use that entire reward bucket, was that they were moved over to the POC bucket. effectively like doubling the size of the POC bucket. So ever since then, there really hasn't been this true division between POC and the DC buckets. So the first economic step here was we wait until the second halving, which is around August 2023, and then we officially dissolve that relationship or that those barriers between those two rewards buckets. And the reason for that is related to the second major change, which is as we shift from a single protocol to a multi-protocol or omni-protocol network, we need to design a system that fairly rewards the various protocols. And you can't look at, it's not apples to apples, you can't look at every protocol the same. So not only do you have to figure out how to reward within a protocol, you have to figure out how to weigh the different protocols and who to reward. And the underlying reason for having POC is to break that sort of chicken and the egg scenario where you need to have a big network to be able to send a lot of data and to have corporate clients on it or whatever you're using the wireless network for. The thing that it's trying to guide us towards in the long run is a network that there's a ton of data transfer over and that there's a ton of data credits being burnt in the process. So ideally, a system would somehow fairly adjust rewards between different protocols, but also provide flexibility for the system so that it drives the Helium network towards protocols that do what the network should do, which is transmit the most amount of data and burn the most data credits. So the system that we designed essentially takes a look at all of the DC burned by all protocols and then allocates proof of coverage rewards based on the percentage of DC burn being done by any given protocol. So if LoRaWAN's doing 75% of the DC burn, it's going to get 75% of the POC rewards in a simplified way. And then if CBRS or Wi-Fi or whatever it is does the other 25%, or one does 10%, one does 15%, it will split the POC rewards in excess of that. Now, the reason why we're waiting until the second halving to remove the division between the POC bucket and the DC bucket is that we understand that the LoRaWAN has become this, massively successful, 160,000 nodes out there, and that we believe it does deserve to be protected from too much encroachment on those POC rewards for a while as it continues to build that network and get to the point where it has sort of large scale usage. So the non-LoRaWAN protocols for the next about 2 years are limited in POC rewards to what was historically the DC reward bucket. So it's about half of the total potential rewards. If CBRS, let's say, burns 30% of DC rewards, it will get about 30% of the POC rewards. If it burns 70% of the DC on the network, it will still be limited to about 50% of the POC rewards. So you have a period where the LoRaWAN holders actually benefit tremendously from having these other protocols being on the network while not really having to defend their POC, the ground against them for a couple of years. And at that point, the division is removed and then all protocols are sort of on the same footing and they can, you could say, sort of compete for the POC rewards between the various protocols. And what's really important here is that one, that the incentive structure that we have is aligning with the long-term goals of the network. So send a lot of data, burn a lot of DCs. If a protocol is burning a lot of DCs, it should be incentivized. So POCs, but behind it, more and more people go into that. You grow that network, and then if something else comes along and 7G, 9G, 15G comes along and it ends up being better, the network will slowly evolve over time to taking that over. It doesn't put any protocol on a pedestal for too long so that pedestal ends up sort of cannibalizing future growth and innovation. And then the other thing is everything we do, should not be from the standpoint, from here on out, in my opinion, should not be from the standpoint of this is what's made for CBRS, this is what's made for LoRaWAN, but everything should come from the standpoint of how do we create an equitable system that is really almost agnostic to protocol or Omni-Protocol, as we say, and those two things, the removal of the division between the two buckets and the splitting of POC rewards based on DC burn percentage, I think lays the foundation for us to really expand the network into as many protocols as really makes sense for the network to pursue.
I want to clarify something for people that, because I've seen this question asked a lot. Doesn't 5G just use a ton more data than LoRaWAN? Won't it just, completely overtake the share that LoRaWAN will have, because these are tiny little packets and, I'm streaming a video in the coffee shop and using up 100 times more than a LoRaWAN hotspot would receive in like 10 years or something like that. It's important to understand that what one data credit means varies per network. So what we're really talking about with splitting the buckets here is the amount of data credits, not the amount of data. So one data credit on LoRaWAN is 24 bytes, whereas one data credit on 5G is how much?
It's I think about 300x more. I don't know the exact multiplier, but it's a lot more. 50 cents a gigabyte is the denominator. For the geeks that are interested, you can open up HIP-27. It should tell you there roughly what that equates to. But you're exactly right in that this is exactly what HIP-27 did, is that we no longer have this hard coupling between DC being 24 bytes. DC is now basically a reflective of the market prices for that particular type of data.
I think a gigabyte on LoRaWAN was something like $420 or $200. It was some insane number of dollars. So it's a completely different stratosphere that LoRaWAN per gigabyte is in.
Yeah, and if somebody wants to, stream Netflix on Helium and pay hundreds of dollars for a single movie streamed or whatever, it won't be quite as much, but still, sure, great, do it. You'll still be paying on the per amount of data used basis. The market will drive the incentives, and this is not going to be easily gameable.
So that's a really key point there, is that data credits are dynamically priced. One data credit is always one data credit. And, I don't know the exact numbers, but basically loading a YouTube video could be equivalent to transmitting maybe 100 packets on LoRaWAN as far as actual data credits are concerned. Everything is priced accordingly. So basically the data credits scale relative to how much throughput each different protocol has in order to make a level playing field and in order to make things just simple to pay for and understand. Obviously, we can't price everything the same. It doesn't make sense. Different protocols use different amounts of data.
And there's a market. There's a market here we have to abide by. And it's the prices that we can charge or whatever the market will bear for that protocol. And nobody's going to pay $400 a gigabyte for CBRS data.
Stepping back a little bit from Omni-Protocol, I think it would be helpful to understand how POC makes sense in a 5G context. Because I think there is a conception that someone will deploy a 5G hotspot, there will be carrier deals in place, people will walk by their home or sit in a cafe near their home and stream a video on YouTube and earn them a few bucks, and that's going to happen 100 times a day, and then you've met ROI. Why isn't that the case? And why does 5G need POC in the same way that LoRaWAN does? Why can't it sort of thrive on this existing install base of phones that are all around us, the initial carrier deals that will be made?
It is true that we will have a number of pioneer trailblazer cellular operators that will actually be offloading into the network day one. But it is not true that we will have critical mass to the point where you just plug in a small cell into the gateway and all of a sudden, no matter what carrier you're on, all of the phones immediately offload. So the initial wave of offload partners that we're focusing on that actually are willing to play ball, actually, MVNOs rather than MNOs. And they do have certain volume of subscribers, but it's not, hundreds of millions of subscribers. So in the end, the situation that we'll end up with is you will see data on the network, but there's going to be a lot of places where, people have invested into a small cell, and it's not an entirely small investment, that will not see data for a long time. And it's kind of like the same chicken and egg problem in that we are able to actually get a handful of folks to come on board, kind of like when Helium was just getting started. We had a few LoRa partners that were willing to come on board. But to really get to a lot of operators to start seriously pushing a lot of data onto the network, you need to have a certain scale to the network. Like if, we have 100 people deploy small cells, then it's simply the effort of signing an offload deal and doing the integration is not worth it to the carrier, because they won't really get a lot of economic benefit. So you need to have some relatively significant scale to the network before it becomes sort of a no-brainer for any operator to come and start just pushing the data to the network. And to get there, and that is like the know-how that Helium has come up with, I would argue disruption behind the whole Helium protocol is that it has this concept of proof of coverage that actually allows for a wireless network to reach a certain critical mass before there is exorbitant amount of data on the network. I think that this concept and this problem about like chicken and egg that we've been talking about in the community is not exclusively limited to LoRa. It is just equally transferable to like all protocols that will be launching on the network, including the CBRS 5G.
I think most people understand that Helium needs to evolve over time, depending on what protocols are in vogue at that point. If it wants to be not a 5-year network, but a 100-year network, 500-year network, I would think of it from the standpoint of like, why would you continue to build new networks on top of Helium if you didn't have some of these systems to help incentivize early networks? You might as well just go off, and this is much harder than I'm making it out to be, but go off and create a Helium 2 that is, 5G specific. You wouldn't have the marketing prowess of Helium. You wouldn't have the massive millions of pre-sales or whatever the number is now to customer base to sort of build on top of, but you would have sort of a fresh set of rewards. It's not like without POC rewards, all this stuff would happen anyways. Like you need to think of, I think, CBRS or any new protocol as starting from a very similar place to where LoRaWAN was only 2 years ago.
The universal rule that applies for virtually all wireless networks is that the value of the network is directly proportionate to the scale of the network. So if I have a network that's one Wi-Fi access point or like one CBRS node in my house, it's not useful for anybody. Nobody cares about it, right? If I have one that is city scale, more people care about it. If I have one that is US scale or global scale, everybody wants it. And solving that problem, getting the network to a certain critical point where it becomes relevant for, the ecosystem at large is what POC helps solve. And that should carry through all of the protocols, I think, that Helium adopts over time.
Yeah. What you just described is basically the essence of the chicken and egg problem, which is that you have a two-sided marketplace where each side is more valuable the larger it is. So how does a new participant on each side reach escape velocity to sort of overcome the inherent detriment that it is to be a small player on either side?
A small network is not going to be attractive to basically anybody, and nobody's going to use it.
You're not going to build for a small network because nobody's going to use it, and nobody's going to use a small network because there's no nodes to be built on.
Based on the definition we have of proof of coverage right now, proof of coverage is the solution to the chicken and egg problem for LoRaWAN. Now, from my understanding of Cellular, by talking to Amir in a previous episode, and just my inherent understanding of radio networks, which is not very strong, but I kind of get the basics, it operates at a much higher frequency than LoRaWAN does. It's about 3.5 gigahertz as opposed to 915 megahertz. And this leads to different properties. So, for example, it doesn't necessarily travel through buildings as easily. In fact, it's much, much, much worse at traveling through buildings because of the high frequency. And this leads to issues if you try to implement the quote-unquote traditional Helium proof of coverage model. Because at the end of the day, unless you have massive density of these 5G hotspots, they are not going to be able to talk to each other the same way that LoRaWAN hotspots do. They really need to be placed quite close to each other because the radius of coverage is simply much smaller, especially in areas with a lot of buildings. So in HIP 37, you proposed an alternative way of doing proof of coverage. And I'm not going to explain it because I think I need a bit of an explanation still. I would love for you to explain it in as simple terms as possible. What is the new mechanism of proof of coverage for 5G and why is it appropriate for this type of network?
You don't necessarily want, and Boris can extrapolate on this, you don't necessarily want overlapping coverage of CBRS. So there is a lot of value in CBRS 5G as mutually exclusive nodes that cover some area that, existing carriers or whoever's buying the data does not currently have coverage in.
Yeah, that's correct. So I think that the current LoRa POC has really been structured to kind of accomplish two things. One is to solve the chicken and egg problem. And I would argue that is probably, one of the most important things, which is equally applicable to all networks. And the second is that, to James's point, it was structured such that it was based on this concept of the hotspots in the system being able to ping each other, right? To create the challenges on witnessing each other's beacons. And the idea there is you want to build a contiguous network. In case of the CBRS 5G, we are not building a contiguous network. We're building, as I showed in the slides, this kind of a bottoms-up community network that complements the macro network. Moreover, and I think that is true of a lot of networks, if not most, in the wireless space, LoRa being an exception, is that this concept of mesh network or hotspots pinging each other is not something that is actually a commonplace in other wireless protocols and is simply non-existent in LTE and 5G. So 5G and LTE before it, the idea there is that a small cell talks to a phone or UE, user equipment, as it's called in the industry. And there is no communication between the hotspots directly. So with that in mind, we basically came up with a new concept of how proof of coverage would work, which I think actually I would argue is relevant not just for 5G and Wi-Fi, but could in a way also be maybe down the road transferable to an IoT use case as well, maybe even LoRa, where basically the idea of a witness, of the role of a witness is actually no longer performed by another hotspot or another small cell or another device that is transmitting the signal. The witnessing is actually done by a client or a potential user of the network. And the usefulness of the location of a particular wireless small cell is not determined by the number of other small cells that are next to it, which James pointed out in case of CBRS actually may not be a good thing, but is determined by a number of devices, or in our case specifically phones, that are in proximity to that cell that potentially have the ability to connect to the small cell. This has two benefits. First is that I think it actually directly aligns POC with this very clear definition of usefulness of the network, because you're no longer gearing towards just other cells being around you. Because even with LoRa, maybe, you can build a bunch of LoRa nodes in Antarctica or whatever. Nobody will ever use them, but they'll still gain POC the way the system works right now. But with this system, we're specifically focusing on the end users that have a potential to offload data into the network. And the key change effectively that we've introduced is this new device on the network, the witness device, where the witnessing function is being done effectively by a cell phone. And the rewards are then split based on the concentration of the cell phones that are capable of operating in the CBRS band that are in proximity to a particular small cell.
Definitely. I have a bunch of questions based on what you just said, but I think it's a super interesting concept. I especially like the part about not sort of counting unuseful areas in the calculation or the reward schedule. Because right now, you could just go deploy a bunch of LoRaWAN hotspots out in the middle of a field. You could deploy 1,000 of them and no one's ever going to use those, but you're still rewarded exactly the same as anyone who's deploying in, let's say, a suburb or a city. So I think that's very cool. The main question that comes to mind is, how are these sort of useful devices or witnesses authenticated? Do they have to be customers of the offload partners, or are they just any random person? Basically, how do you prevent Sybil attacks from exploiting POC?
So this is a very good question. And there is a lot of detail in HIP 37 about it. And unlike the first time where we just kind of tried to wing it, we spent a lot of time and a lot of iterations with various community hacking experts and things like that. And we've found a bunch of holes and we've reworked it multiple times. So to answer your specific question, the general philosophy with respect to how this POC paradigm is being implemented that we followed is to try to change as few things as possible with respect to, how the current proven LoRa POC has been implemented. So if there is a solution in the LoRa world for it, can we just repurpose it and not invent or reinvent the wheel? That was kind of like the general philosophy. And when it comes to authenticating the devices, we kind of generally followed the same overall philosophy, in that this problem has already to an extent been solved in the LoRa hotspot space, where anybody who makes the hotspots, they need to be like an approved maker. They have their own maker account, and the onboarding server prior to issuing security keys for the hotspot actually has a list of the MAC addresses of all of the hotspots, and the security keys are not extractable or transferable from one hotspot to the other. So this has kind of been a mechanism that's been implemented for LoRa, and we thought about how can we kind of repurpose that for the cellular world. And in the cellular world, it'll work in a similar way, in that you have a maker or a manufacturer, in this case, is basically replaced with an eSIM infrastructure operator. So for me to get a SIM, which you can think of as like the way that devices would authenticate to the small cell, you need to have a SIM. That SIM would need to be issued by a DY approved eSIM infrastructure operator. The process for which is like very similar to how it would work in the how do I become an authorized approved maker. Now, all of the devices in this case, so people said, there's a difference between an eSIM and a physical device in that the hotspots are actually being built by the makers, and an eSIM is this like virtual thing that you would preload. But it's not entirely correct in that you must have an eSIM with a valid witness key to be able to perform any kind of mining on the network. And the eSIM, despite being not necessarily a physical device, is bound to a physical device, much like a miner code is bound to a physical hardware device with a security key embedded in like the security storage. So in the hotspot situation, most of the devices have like a MAC address. In case of the phones, you have something called IMEI, which is this standard, you can think of it as like a MAC address that is always assigned to a phone. It is generally illegal and relatively hard to change it. But if you want to hack it, you can change it. But the thing is that this IMEI gets bound to the eSIM authentication vector. So for any device to be able to actually mine on the network, they have to connect and authenticate to the small cell by providing the pair of an eSIM that is bound to unique code, this IMEI. So if I, for example, have a device and I got an eSIM and it got onboarded, and then, I want to try to virtualize it and I want to create a bunch of IMEIs that are virtualized, you won't be able to get on the network because there's only one specific IMEI that is bound to one specific eSIM that is controlled by the manufacturer, and that is also bound to the security key that is provided by the onboarding server. So we basically swapped a few concepts that have been proven to be safe in the, the manufacture of hotspots land with some of the concepts that are common in the eSIM and end user device in the cellular world land, without necessarily doing a lot of changing to the process to make sure that it's secure.
That is really, really interesting. So you're essentially bootstrapping the security of the cellular fleet on basically an existing sort of security mechanism that exists in all cell phones, which is they have this hard-coded IMEI. So from my understanding, if you wanted to spoof anything, you would need to you need to have the security key, and you'd have to also know the correct IMEI. So it's not possible to easily change the IMEI on a phone to be one that you want it to be. How is the IMEI secured and prevented from spoofing?
You can change IMEI all you want, but you think of like authentication is not done simply by IMEI. It's done by the pairing between the IMEI and the eSIM that's been issued against that particular IMEI. So if you change the IMEI, then you no longer are able to basically connect to any of the small cells. And that is generally how it works in the cellular world, is that eSIM is authenticated against a particular IMEI on the phone. So it's the combination of the two, of which the eSIM component is actually controlled by the eSIM infrastructure operator, which can be revoked or granted by this authorized entity. You need the combination of the two to be able to get onto the network and to be able to mine. So even if you change IMEI, it's not going to change anything, because it's, you basically say, I have this IMEI, and then the eSIM infrastructure operator says, okay, I take this IMEI, I append basically the eSIM to it, and that becomes security element against which you get your witnessing key. If any of the elements in this chain changes, then you're no longer able to connect. And the witness key, as well as the eSIM, are controlled by a trusted entity.
So it basically wouldn't be possible for me to, say, have an eSIM issued to my phone, which has a certain IMEI, have it fully signed, and then transfer that to a new phone and try to load that eSIM onto a new phone where the new phone's IMEI is spoofed to be my phone's IMEI.
This is actually one of the things about eSIM that a lot of people argue to be a disadvantage, that in this case is a useful feature, in that an eSIM is bound to an IMEI, and it's the combination of the two that actually enable the phone to connect into the network. And that is why some people argue that like a physical SIM is better than an eSIM, because a physical SIM you can just put into a different device and it will authenticate. If you have an eSIM on a device, you can't just take it out and put it into another one. You basically have to go to the vendor who has to issue a new eSIM against the new device for you. And that authentication has to happen for every time the device basically changes.
Got it. So you basically have these DY-approved vendors that are issuing the authentication for an eSIM, which, if you want to create a parallel to the LoRa world, essentially creates a secure element within your phone that is not, basically extractable.
Yes, exactly correct. And the third component is the same as in LoRa. You also get the effectively like a witness key or like a mining key. So every device on the LoRa network actually gets a key from the onboarding server. You don't just give a MAC address and that's it, and any MAC address can. You have a onboarding server issue a security key for a device that goes into the security chip, right? On like racks, it's an ECM chip. On Bobcats, it's an ECM chip. In case of a FreedomFi gateway, we use a different mechanism called a TPM. It's a mechanism for storing a security key on a device without the possibility of extraction or the possibility of changing. So that same concept is still going to be present, because for both the iPhone and the Android, there is a similar construct to like a TPM or an ECC. It's called, I think, like keychain for one and something else for the other. But it's basically the same idea, where you have actually a place where you can securely store your authentication keys without the user being able to like hack the system and extract it. So if the IMEI and the eSIM pair is still somehow magically gonna end up being hackable, which I don't see, because this is like a way of authenticating that has been approved by the cellular industry in general. So like if you can hack that, you can have free data plans, unlimited on Verizon or whatever. But if that is somehow possible, then you still have an also added layer of security that is just exactly the same that you get with the hotspots, where you store the mining key in the secure element of the end user device.
That's a really good explanation. I'm very excited about this sort of new path that you guys have found. Another interesting thing that I don't think anyone's mentioned yet is that this brings a new class of participants onto the network, which are basically, I don't know what you want to call them. Maybe you have a name for them in the latest doc, but I'd call them professional witnesses or something like that. People who download an app or authenticated via eSIM and then are rewarded via mining rewards for witnessing and basically connecting to 5G hotspots. Is that how that works?
Yeah, professional witnesses. Yeah, no, that is exactly how it works. And I agree that is a huge added benefit in that you have this new constituent of professional witnesses. And there is another added benefit here in that these professional witnesses, they can professionally perform the function of mappers for that network, right? So these professional witnesses can create an aggregate kind of a view of the network profile that can be exposed, and that model can be used to actually model the savings or the benefits that an offload operator will gain from the network by actually offloading into it. Because what they're doing effectively is they're simulating a network offload scenario, right? And by doing that, you actually have a very securely validated map of coverage that the network provides. And through that map, you can basically model what that could translate to in terms of data savings to an offload operator. So if I'm an MVNO and I'm paying somebody like AT&T or whatever, $2 a gigabyte for my network, and the Helium network is selling the data for 50 cents a gigabyte, using that, I can map the professionally mapped Helium network to my economics and immediately understand how much money I would be saving by actually introducing the Helium network into the picture.
I've been dreaming of this incentivized mobile network since the discussions of what do they call them, the golden tabs back in the day, where you'd have these certified witnessers of LoRaWAN units. And I always dreamed of getting a Sprinter van and throwing up an antenna on it and just traveling around America.
Yeah, and the third benefit that I would tout also is that one of the biggest concerns, I think, that a lot of the MVNOs that we've been talking to about offloading has been, the reliability of the network, which is, rightfully is the concern. Concern is okay, well, we're going to start using it, but some idiot, whatever, connected an IoT backhaul to the CBRS node and it's not going to work, or they just turn it on and turn it off or whatever. You can't guarantee the reliability, right? So I think that this POC indirectly, because it's actually such a close approximation to how the offload would actually end up working in real life, serves the function of actually validating the reliability of it too. So if you are, let's say, an MVNO and you have a certain subscriber base, you can just embed that witness functionality through an SDK into the app that you may already have, and don't get anybody to offload. They just have the people basically walk around and continue using exclusively, your primary AT&T service, but also in parallel do the witnessing. You will get kind of a first-hand validation of how it can work, because the difference between doing the witnessing and actually doing the full-fledged offload is just flipping a small switch. You're still performing all the same functions. The UE is authenticating into the network, and there is some small amount of data transfer that actually happens between the small cell and the UE. And it's all exactly the same as if the offload was live, except the customer base could be just doing the mapping and not offloading anything. And not only is it a way to get more people to get exposed to Helium in a lightweight kind of fashion, it's also a much easier on-ramp for a lot of the offload prospects to kind of get comfortable with the network.
This is a really very interesting symbiotic relationship you've discovered here, where you get people to validate the network and map the network at the same time while incentivizing them by basically subsidizing their cell phone bill. And they don't even have to do anything. They just have to go about their normal life, which I think is so crazy. I don't know why it reminds me of this, but it kind of reminds me of the insight of TikTok, which is people are already watching the video. And by measuring how long they're watching the video, you can know how engaging the video is. And then that's $1 billion company. Like that insight right there is $1 billion company.
We're verifying the network with what the network's supposed to do. In some ways, even a better approximation than what goes on with LoRaWAN, where it's just two units that might have massive antennas sitting up on roofs being able to communicate. Like what really matters with LoRa is that little node that's at street level 2 miles away actually going to be able to communicate with either of those antennas is a little bit of an abstraction versus that's literally communicating with the types of devices that the network is built to communicate with.
Yeah, exactly. And just like Arman, to your point, with some of these big ideas that now in hindsight are so disruptive and obvious, I think it's kind of similar in that the reason why this is only possible now is because of a number of things that have just become available recently. So eSIM wasn't around, like people have been talking about eSIM forever, but it's only now higher end phones come with an eSIM embedded. And going into the future, it's definitely going to be majority eSIM, but until recently that wasn't there. Like you didn't have an eSIM, so you couldn't do that stuff. CBRS, that happened in January of last year. There was no shared spectrum. You couldn't get spectrum without going to an FCC auction and spending $1 billion. So it's really a combination of a lot of these factors that kind of like come together right now that enable this kind of model that I think probably, a couple of years from now, we'll be kind of looking back and everybody's going to, oh yeah, of course, that's how it should be working. Like how could it be, different? But actually, because a lot of the infrastructure wasn't there until recently, it just simply wasn't possible to do it, even 2 years ago. There's all these devices out there with an eSIM, and most people don't even know they have it, right? So it's like completely underutilized asset. There's a few tech-savvy people that are like, oh, I'm going to travel, I'm going to download an eSIM, but most people have no idea that it's even there. That's an opportunity to turn this underutilized asset into a moneymaker.
Speaking of money making, let's zoom out a second, back into HIP 37 land. So I think there's some skeptic questions that I want to go over, because the concept of expanding POC to non-LoRa protocols is something that comes as a bit of a shock to LoRa participants. Thus far, anyone running a Helium hotspot and providing LoRa coverage has been receiving all of the proof of coverage rewards. So I'm a LoRaWAN host. Why should I be okay with basically my proof of coverage earnings potentially being reduced, even if it's from that data credit bucket, right? Like, because proof of coverage is currently spilling over into the data credit bucket. Data credit usage is like 0.01% of all the rewards on the network. If proof of coverage is allocated to a new protocol like 5G, it will be removed somewhat from LoRaWAN hosts. So why should I, as a LoRaWAN host, be okay with this? What is the benefit potentially to me?
I think that's a very good question. And I think looking at it from the standpoint of I'm getting X number of rewards now, this is going to change the number of the pure HNT rewards. It's going to reduce that. It's similar to when we started mining, Arman, and like 50 HNT day was like a bad day on like a hotspot. Like we earn much less now, but we're part of this, it was one of like 1,000 hotspots out there versus one of 160,000, and a similar sort of price increase of HNT. I think that the short-termism of looking at like, okay, I'm going to see this, decrease sort of ignores the fact that this network only exists in the long run if we're burning enough DCs and sending enough data to essentially be self-sufficient at some point in the future, that the amount of quote unquote revenue or data credits being burnt into the system eventually needs to support the system, much like a top-down system, needs to be supported by the revenue. With the amount of POC that we have today, we sort of forget that at some point the system sort of has to do the same thing. And there's sort of two ways of looking at it. One is that, do you want to be part of a system that has no flexibility in what technologies it's going to rely upon? Like anybody that's read like Innovator's Dilemma knows like the story of the old companies always being pushed over by the new companies, and every generation of new disk manufacturer saw like an 80% shedding of incumbents because they didn't want to cannibalize their current revenue with some new technology that was coming along. And history has shown is that those companies don't last very long. They don't make it through too many generations of technology. So I think just from a lasting standpoint, if we see this as helium as something that's around for more than 5-6 years or whatever it is, and it's something that can be around for 100 years, there needs to be these mechanisms to allow for flexibility of technology. And then the other component is if you are earning HNT today for LoRa, you're probably going to benefit the most of anybody in the history of helium from the DC burn of future protocols. Because let's say that CBRS does end up being 1,000 times bigger than LoRaWAN or whatever the number is, 10 times, 100 times, 1,000 times, million times, and that it ends up burning that proportional amount of DCs. And that ends up driving the burn to mint economics to the point where the HNT token price needs to, sort of account for that DC burn. You are earning based off of a technology now, LoRaWAN, but because you're holding that almost like a little sliver of equity in call it the system that is helium, you will benefit from all that stuff going out into the future. And let's say that HNT is $1 based off of the LoRaWAN system, or $20 like it is today. And then with CBRS tacked on top and the amount of DC burn, it's $2,000. You're benefiting from that entire difference delta between that $20 and that $2,000. So, you're really sort of shooting yourself in the foot if you're looking at it purely from the standpoint of one HNT equals one HNT. There's one HNT under the LoRaWAN system, just like there was one HNT under the pre-HIP 20 system. And then there's this just dramatic change in becoming this Omni-Protocol network that makes that one HNT such a higher potential unit of economics. I just think it's a sort of a short-term look of things to say that there shouldn't be any sharing of these rewards because, LoRa was here first or whatever it is. Anybody that ever owned a LoRa unit is going to benefit more than any other protocol in the history of helium from this becoming an Omni-Protocol system and those new protocols burning hopefully exponentially more DCs through exponentially more data transfer in the future.
Yeah, I guess another way to put it, simplify the model a little bit, is from a game theory perspective, would you take a 50% cut in the raw? 50% is like an extreme example. That means that 5G would be taking half of all the POC rewards. So this is like the most extreme example. Would you take a 50% cut in raw HNT terms to gain the economic benefit afforded by the burning of all the DC that 5G could potentially burn, which would cause the price floor of HNT to rise possibly much more than that 2x? Yes, you may have less in HNT terms, but in dollar terms or Bitcoin terms, whatever you're measuring against, that DC burn pressure could create such upward momentum on the price that it wouldn't really matter. And this also answers the question of sustainability in the future. That DC burn creates sustainability in the future because, the higher the dollar value of mining is, the higher the dollar value of HNT is, the more miners are rewarded. And since miners are buying their hardware in dollars, that's really all that matters. So if anyone does anything that raises the HNT price, they are literally causing physical infrastructure to be built through a direct incentive. It's kind of like bringing in another investor in a certain sense. The people who are buying 5G data credits to use the network are the investors, and you are basically getting a return from their usage.
Yeah, and I always say, when it comes to POC and things like that, this network's going to require the market to fund a lot. And really, when I say in the market, I mean, what is the premium that the exchange market, that investors just buying HNT on exchange are putting on the system? And to be blunt, there's a lot more excitement about 5G and things like that because they're technologies that are en vogue, even outside of helium than LoRaWAN that even I had to learn about. I think most people, unless they were in sort of radio, I'm sure Boris has known about it forever, but I had no idea what the hell LoRaWAN was when I got involved with helium. And so now you have something that is much more sort of digestible to a lot of people. So I expect that has already had a effect on the price of helium. And I expect as helium gets more and more into 5G and gets identified with 5G, that will create a significant market premium that is really, as Arman said, funding the growth of the infrastructure of the network.
Yeah, I think that you guys pretty much covered it. I don't know if I have a lot to add. I think in general, the short answer is that I'm fairly confident that bringing other protocols to the network will increase the price of HNT over time. And on the flip side of it, I think it's important to understand that hard coupling market capitalization of the Helium network to a specific physical implementation of just a single protocol is not necessarily a great idea, because the wireless protocols, they change all the time. And even if a protocol doesn't change, the physical hardware changes. It's a fast-moving, fast-evolving technology world. Ever since the whole concept of blockchain was born, I probably have changed like my Wi-Fi router 5 times in my house, because we didn't even have like Wi-Fi 5 at that point, and now we have Wi-Fi 6, right? So it's the same thing. Even if you don't go into things like cellular or 5G and just even strictly say that let's have Helium be exclusively an IoT network, I mean, the same true rule applies. Even LoRa will change over time. And even within IoT space, there is a continuous battle of protocol wars that eventually there is the next new thing that comes up, and it is just better implementation because it learned all of the mistakes from the previous protocols and it got better. So I think that in general, it's important to have an incentive system such that Helium evolves together with the space of wireless protocols versus being hard coupled to just one forever. And that will directly translate to an increased value in HNT price that will benefit everybody.
I'm going to throw out another question that skeptics may have here. You put up a slide earlier that shows that FreedomFi is planning to ship maybe 4,000 units by January 2022?
10,000 to get all together.
Oh, so those numbers are not cumulative.
They are not cumulative, no. But still, compared to whatever, hundreds of thousands that probably need to be deployed, I agree. I suspect I know where you're going.
You agree with the question. I think you know where I'm going. So with so few units on the market, how is this essentially, fair that such small a number of people who are on the reservation and wait list could benefit from the CBRS POC rewards when there are, hundreds of thousands of LoRaWAN units already out there? How will we prevent concentrating the rewards into the hands of the few that manage to get FreedomFi gateways?
I think on the economic side, there's sort of the two components that I talked about earlier that both protect existing protocols to some degree. The one being by not dissolving the DC bucket until 2 years out, new protocols can't really dig into that really 50% of POC rewards that are locked into LoRaWAN for the next 2 years. So whether it's 100, 10,000, 100,000, 10 million, even if there's more 5G units in a year and a half than there are CBRS units, they won't be able to flip over into the POC bucket until the second halving. And then the other one is that a network is only being incentivized with POC when it's actually burning DCs under this new model. So the split of POC, again, is if you're only burning 10% of DCs, you're only getting 10% of the POC rewards, which means the other protocols are getting the other 90%. So a protocol really needs to prove its worth under this system to get any POC rewards. So, it's not like if Boris and FreedomFi have 500 units out there that they're automatically going to get the entire DC bucket. They're not. And a very small percentage of them are probably going to overlap with those trailblazer MVNOs that we talked about. So early on, that DC usage is going to be really small. And I think that's a pretty fair way of comparing protocols. And there is an argument of should there be a earlier incentive bucket for before you burn any DC credits? Should there be 1% or 5% or 10% that goes to new protocols to sort of initiate and incentivize protocols before they have any chance to do DC burns? Because even under this system, there's still a chicken and the egg system. We're not relieving CBRS completely of the chicken and the egg problem. If it proves itself a little bit, it has some room to, prove itself a little bit more. And that applies to, not just CBRS, but every protocol that would come onto the network going forward.
Yeah, it's just because the way that it's structured is tied to the amount of DC burn. So the amount of POC that gets relocated to the new protocol bucket is directly proportional to the amount of DC that this protocol burns. It's kind of a self-regulating mechanism in that, if just the few coveted 10,000 people got these things, there's only going to be 10,000 devices to create that DC burn to get that POC shifted to that pool. And at the same time, the network is benefiting as a whole from the new protocol being on a network and hopefully is positively affecting the price. So it's not like one guy got one 5G miner and all of a sudden just like all of the POC went to this one guy and everybody else was starved. It's going to get proportionally allocated as the network grows and as it drives more DC burn on the network. I would say that the way that the economics have been devised in attaching to the DC burn to a very large extent mitigate that issue.
It helps prevent some of the stuff that led to HIP 10, where no matter how many DCs were burned, there was a set number of rewards being pushed over there, and it created all these weird, odd incentives. It's a fair mechanism to compare different protocols. And not only that, but the bucket that we're talking about, the DC bucket, still has the DC burn rewards in it. So as DC burn rewards come up, those are actually cannibalizing of the non-LoRaWAN POC rewards until that barrier between DC and POC rewards are dissolved at the second halving. So the LoRaWAN rewards don't really have to worry about what percentage of rewards are going to DC or to data transfers. But for the non-LoRaWAN, they're fighting for the same bucket of funding as the DC rewards.
With this new mechanism, how is the cold start problem for new protocols addressed? So like LoRaWAN, for example, it's going to start with zero usage. Let's say there's another protocol like that. You mentioned a 5 to 10% potentially bucket that just, I guess, new protocols could be voted into via governance. Is that how that would work?
This is not in this HIP. I should clarify. This is one of those examples of what we talked about earlier, where different ideas were floated that could improve this HIP. And I think I would personally love to see some kind of innovation bucket that, let's say, a protocol, after it's been sort of voted into the network, much like CBRS was in some ways voted into the network with HIP 27, that there's a designated amount of rewards that could go to those. But right now in this HIP, we didn't add it. We think that CBRS has an opportunity to get some data usage, albeit small, right out of the gate. So it's not in exactly the same boat as LoRaWAN, where some very small hobbyist things, there just wasn't sort of any kind of opportunity. That being said, it's hard to say if that will apply to future networks. It's hard to say if that's a big enough incentive bucket. I think something that is sort of important to hear is that there also needs to be enough incentive on the sort of app side to give people incentives to be witnesses on a large scale, because it's not like you have a LoRaWAN antenna that's going to get 4, 5, 6 miles of coverage. You're going to get a relatively small area of coverage. So the verification and the witnessing application, there could be many magnitudes of people that need to be involved with that, but they are being very helpful to the network. I think that the fact that there, in theory, should be some DC burn right out of the gate gives CBRS a little bit of a kickstart compared to, I don't know, putting up a singular satellite, or like whatever that next wireless protocol what we're talking about in the future that is absolutely useless as a very small, like LoRaWAN is actually a good example of that, because there needs to be this sort of contiguous network of these things. It's much less useful than like an individual node of CBRS, but nevertheless, that will be a very small amount of data usage, and the network really needs to prove itself. It needs to sort of chip away at those POC rewards, and then every time it makes some progress, it gets a little bit more incentive and a little bit more funding to make more progress, as I think most great ideas and companies and everything else, that's sort of how they operate. They operate with very few resources. They prove themselves, they get more resources, they prove themselves, they get more resources, in sort of a virtuous cycle.
I guess the last hole I want to try and poke here is in what you just said, which is that you can essentially buy more resources by proving yourself. Well, proving yourself is actually really very simple. All you need to do is burn some data credits. And on a blockchain level, you could do that with your own router without actually even having a real device. Basically, you could spoof data credits. And, I do see an arbitrage opportunity here for, someone who's operating on any protocol to start burning more data credits and thus increase the share of proof of coverage to their protocol. Now, they wouldn't be rewarded on like a 2-to-1 basis or anything. It would be like 1.001 to 1, because that person has to be already getting a sizable share of the POC rewards for themselves to make it worth it. Is this something we're concerned about? Is this an actual risk here where people can sort of buy more proof of coverage rewards for their protocol? Or are we making an assumption like there will already be too much burn on all the protocols and it'll be too expensive, or that just any burn is good burn? Or, what's the assumption we're making here?
It's not going to be possible to buy proof of coverage because the amount of money you need to invest to offset the proof of coverage bucket to make up what you've spent on data credits and purely proof of coverage the math's not gonna stack up. And I think you can play with the model that James helped put together, and you'll be able to see that exact thing. So the way it's gonna work is that you don't specifically, you have one small cell, and I'm gonna go and buy data credits against that one small cell, and all of the proof of coverage is gonna go to this one small cell. It's gonna be an aggregate amount of data that will drive the aggregate amount of proof of coverage returns that is going to be equally divided by everybody. And that's kind of the whole point of it, right? It's that we expect that some people will have a small cell in a busy mall that will drive a lot of coverage, but some people might not have access to that and might be putting it in the less trafficked areas, and they should still benefit from the proof of coverage bucket for the data in aggregate they have a fair claim to. So because of the way it's structured, you can't directly game the system this way, in that you will always have to be spending more of your personal money in terms of buying the data credits than you will be making up personally from simply gaining the additional proof of coverage.
A term that's come up a lot is that even in an unlimited plan, it's not really unlimited. You can't go out there on a consumer plan and start sending petabytes of data. You're going to get kicked off your plan. And at CBRS, if there's any sort of meaningful amount of data to be an individual to impact that, I think the scale of the amount of data that you're going to need to be transmitting over this thing, you're essentially dooming yourself to be kicked off the network or your carrier or whatever it is. And you have to be on one of these carriers that, are an early adopter of the network. And you're taking a lot of the onus on yourself to improve a protocol, prove it for everybody in the protocol, when you're likely to have a very, 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 very small sliver of the benefit that would do. No, I don't think that, you could easily double the bandwidth going over CBRS yourself without seeing negative consequences as a result.
So what you're touching on, that's a different type of gaming, where we actually explicitly described that at the very end of the HIP. The idea is that you can subscribe to an operator unlimited plan and then go and farm that plan. Stream videos on that plan and get DC rewards for it, and pay a fixed amount for unlimited, but actually get compensated on the back end in larger number of DCs that you put through your small cell. So it's a very hypothetical scenario, because we frankly, despite, the best efforts, don't yet have an MNO with an unlimited plan who is ready to offload into the network. But even despite that, there is some protections that we've built in that are more described in detail in the HIP. Despite even the protections, it's kind of making the assumption on the behalf of the Helium community that the offload partners don't know how to manage their own data costs and traffic. Because this concept of MVNO offloading data into a third-party network is not entirely novel. And MNOs and MVNOs, they really know how to manage their data costs and how to quickly catch people that are trying to abuse the network and throttle them and things like that. They're much more sophisticated in that than I think that any of us will ever be, because that's their core business. Just to be safe, we have put some hard precautions in there that we've described in the HIP, but I think that it's not a very likely scenario. Although it doesn't have to do directly with the question, Arman, that you've asked initially about, it's kind of an edge case of buying your own data and buying your own POC sort of thing. But
yeah, I remember this was brought up, and I'm glad you mentioned it, because I forgot to even ask about it. But that's a very interesting point. I don't know if most people know that unlimited data plans are basically like health insurance or something, right? There's one really, really sick guy who's 92 and using 2 terabytes of data per month on his cell phone. And the rest of us are paying for that. And then there's this totally healthy 6-year-old girl, which I guess actually in the cell phone world would be the grandpa, who uses 0.1 gigabytes and still pays $80 a month. On average, it works out to be ridiculously profitable for the carriers, but they do a lot of magic on the back end. Well, part of it is just economics, right? But I'm sure they also do a lot of throttling on the back end to sort of manage their sick patients.
Yeah. Deny coverage for extreme cases.
That's right. It's a really interesting. I mean, there's so much complexity here, but I'm glad we got to dive into, as many bits of HIP37 as we did. I think when you both first invited me to discuss HIP37, the first thing I did when I arrived was I delivered, I'm pretty sure, like a 3 to 5 paragraph essay about all the things that I thought were like ridiculously wrong with this, or like, oh my God, I see so many obvious holes here. And I like to think of myself as an optimist, but I really did feel like a pessimist stepping into the conversation, being like, come on, guys, how are you going to make this work? But to both of your credit, and to many other very smart community members and FreedomFi people who have basically just grinded on this thing and ate glass, as Anatoly from Solana likes to say. You've put a tremendous amount of work into refining the ideas here, and I think it's to the point where I look at HIP37 and I don't see any flaws that are so glaring and obvious that I'm like worried about it or anything. In fact, I think these are very complex ideas. There's a lot of different parties involved and a lot at stake and a lot of different technical implementation details. And it takes time to even just understand like all the little different things that are going on. So I think I've reached a point personally where I'm excited about HIP37. I'd love to see it pass. And my last question to you guys is like, where do you think the community stands on this? I know, James, you've had a lot of conversations with people, and what kind of feedback are you still looking for from the community?
If there's obvious holes, we should fill them. Every time I read the HIP, there's a whole bunch of stuff that was worked on by Boris and Abe, and then a slew of other people, and Arman, you've been involved. And a lot of people have been passively and actively involved with this, that every time I read it, I'm like, oh my God, that's like a genius solution to this like complaint that came up. So I think a lot of it is there right now. I'm not a security expert by any means, but I don't see personally a lot of sort of obvious flaws. I do think it's important to realize that like we're on POC like 11 for LoRaWAN, like whatever number we're on, these things also evolve. So they're not going to be perfect out of the gate. There's going to be, more protections that are going to evolve as we go. And I think making sure people are sort of bought into the Omni-Protocol aspect of this is, what's really important for me personally, because, I don't really look at it as like, oh, the network is better Omni-Protocol. I look at it as like, that's the only chance the network has is to be an ongoing, lasting entity, is to be Omni-Protocol. I have zero faith that any technology is going to have an infinite lifespan. So making sure that we are via CBRS, which is, in my opinion, the best possible vehicle to do it with, establishing the foundation to make the network Omni-Protocol, is what's really important to me. And any way that we can improve that transition or make the network more accessible to Omni-Protocol. I hesitate to say it, but I sort of dream of like almost like a protocol agnostic network where like really anybody can throw any protocol, on it with some, guardrails or not with any guardrails. I don't know. I might be thinking too far out here, but I love that idea of Helium, the blockchain that is Helium, or the system that is Helium, doesn't really give a damn, what protocol you're putting across it, and it can sort of handle any protocol that you toss at it.
Yeah, I've had crazy fantasies personally of, wireline networks eventually being on Helium, or really anything that could, like anything that exists in the physical world. It doesn't necessarily even have to be a communications network. Just something where there's a sort of supply and demand could exist on Helium. You could take this existing protocol and apply it to anything, really. It doesn't even have to be networks. But all that being said, one thing that I want to just solidify here, because I think we all share this view strongly, is that none of us are bearish on LoRaWAN. None of us think LoRaWAN is a lesser protocol or not worthy, or we all strongly support LoRaWAN and want LoRaWAN to succeed alongside other protocols with Helium. And I think LoRaWAN has an insanely bright future. Anyone who's currently involved, on a personal level, you have tons of growth ahead of you. If you're mining now, you can reinvest and build the network in your area. If you look at the DYETL dashboard, there's finally some serious usage coming on the network. And One metric I added to that dashboard myself was number of hotspots transmitting data packets, which is super interesting to see because if you look just 3 months back, there were only about 5,000 hotspots on any given day transmitting data packets from real devices. And the last time I checked, it's like 55,000. So that's a 10x growth, the number of hotspots transmitting real data packets in just 90 days. That is insane. The growth trajectory of the LoRaWAN side of things is still exponential, and the amount of data credits being burned is also on an exponential growth track within LoRaWAN itself. So LoRaWAN is absolutely killing it. It's not going anywhere. It's just simply the first piece of a wider view of what the Helium network and Helium protocol can be.
Yeah, I agree with everything said. I also wanted to express kind of gratitude to the community for helping put the glass in our mouth, so to speak, because I think that's been it's been a long journey. And, now I think that most people, when we threw that out there with HIP-27 a while back, everybody was like, oh, what the hell, and they just threw a lot of feedback our way, most of it around the security vulnerabilities. And I think that if it wasn't for some of the folks in the community sharing those perspectives, we would have never thought about it. And now in hindsight, it's been a good collaborative effort that I think truly made HIP-37 get to the point that is actually viable. So I think that the exercise that we went through by socializing into the community is essential, not just from the standpoint of getting the community kind of comfortable, but also from the standpoint of solving a lot of hard technical problems that we ended up needing to solve to get HIP-37 to where it is today. Hopeful that we are close. And specifically to your question about what additional feedback, I think the kind of gameability security side of it, which is where we've gotten most of the feedback, is the area that from our standpoint, as I mentioned, probably a biggest gap on our team, right? So we come from the enterprise open source software background, not from the blockchain background. So the whole thing of how it can be gamed is not something that we're personally experts at. So to the extent that there's still holes there, kind of a continued feedback and continuous improvement loop is warranted.
Great. I would encourage anyone listening to check out the new FAQ on the FreedomFi website. There's also an extended FAQ doc that I believe is linked. Is that pinned in the CBRS 5G channel? Where can people find that?
Yep, it's pinned there.
Excellent. So that's pinned there. I highly recommend people check that out because it's got a lot of details, just tons of extra details that if you have a very specific question that we didn't cover in this episode, it's probably covered there. I'd recommend everyone go read HIP-37. There's a lot in there, and definitely provide any feedback, especially if you see anything that you think could be improved on that we all haven't figured out already. And lastly, I'd like to remind everyone about the DY grant program. If you're looking to make big improvements to anything from gaming to analytics to infrastructure, I'm sure even marketing, DY has an amazing grant program. That's at dewi.org. You can apply there. If you're thinking that you could make a big improvement, but you're just lacking the funding, or you've got a full-time job and you can't afford to do it, I've seen a lot of awesome projects funded there. Do you want to give a slight plug to your redenomination HIP here?
It's similar to what would be a stock split in that if you had one HNT today, post redenomination of 1,000 to 1, then you'd have 1,000 HNT. But it's not just so you have more HNT. It helps the incentives around how people earn via mining. People are now mining anywhere from 0.2 to 0.5 HNT per day. That's about to decline by another probably 10x over the next year, if not more than that. And psychologically, that has a negative effect on people's excitement of mining. And so just redenominating the token essentially means you're changing the number of bones, which is the underlying unit, much like Satoshi's for Bitcoin. You're just changing the number of bones per HNT. So there's more HNTs in the system, but there's no more bones in the system. And it should both help incentivize people because they're earning full units again, but also these kind of redenominations or splits tend to have a significantly positive impact in the markets from a token price standpoint. So hopefully, as we talked about before, it's not just about price of the token for current holders. When price increases, you're literally helping fund further development of the network. So anything that can help sort of secure the price of HNT is hugely beneficial to the network moving forward.
Love it. Slick pitch. I'm still working on you to change the name of that HIP to Unit Bias, aka why are Cardano and XRP in the top 10 a history lesson. But until I manage to get you to do that, I think everyone should read the draft that you put out. Have you put that out yet, or is it still in the works?
I put it out on the Helium Improvement Protocol, sort of the master channel. I'm trying to secure HIP 40. I was on HIP 20, and I'll have to come up with something else for HIP 60. But I like the even numbers, so I'll get Jamie to make me a channel when I can secure HIP 40. That is up there already on that master channel, and there'll be a sub HIP channel sooner than later.
Well, everyone go check that out in Helium Improvement Proposals in the Helium Discord. Boris, James, thank you so much for this awesome in-depth discussion. Really excited to get it out there. If anyone wants to reach the two of you for feedback on Discord, how can they reach you?
Oh, I'm everywhere. at JMF is my thing.
I am at 0 tweets on Discord, and I am in not everywhere like James, but in the CBRS 5G and the HIP 27 and the HIP 37.
And I am at Arman. We actually have a channel for the Hotspot podcast. So I'm sure if you have any feedback on this episode or any other episode, please drop it in there. And, we'd all love to read it. Guys, thank you so much for your time. This has been an awesome ep. Until next time.
Yeah, Arman, thanks so much for having us.
Thanks, Arman. Appreciate it.
Take care. Thank you for tuning into the Hotspot. If you love our content, don't forget to subscribe on your favorite podcast platform. And if you want to maximize your impact, leave your honest review on Apple Podcasts. Your support helps us reach more listeners and educate them about the Helium Network.